Right, let's get one thing straight. The internal combustion engine is, without a shadow of a doubt, the most important invention in the history of the world. Forget the wheel, forget sliced bread, and certainly forget the internet. None of that matters if you can't go anywhere. The internal combustion engine is the beating heart of our modern world, the noisy, fire-breathing soul of every proper car, lorry, and motorbike. It's the thing that gives us freedom, the ability to cross continents, or just pop down to the shops for a pint of milk without having to ask a horse for permission. It's a masterpiece of engineering, a symphony of controlled explosions that turns liquid dinosaur into pure, unadulterated speed. So, what is it really? In the simplest terms, it's a box where you set fire to things. Specifically, you set fire to a mixture of fuel and air. This isn't a gentle, romantic campfire sort of fire. Oh no, this is a violent, instantaneous explosion that happens hundreds, even thousands of times every single minute. The clever bit is that all this violent energy is captured and harnessed to do useful work, like turning the wheels of a magnificent V8 muscle car. It's called internal combustion because, unlike an old steam train where the fire is outside the engine, all the action, all the drama, happens deep inside the metal block. It's a contained catastrophe, a tiny war happening over and over again for your personal amusement and transportation. Imagine a tiny, very angry god trapped in a metal bottle. Every time he gets angry, he lets out a massive shout, a burst of energy that pushes everything away from him. Now imagine you have several of these angry little gods in a row, all shouting in a perfectly timed sequence. That, in essence, is what an internal combustion engine does. It's not just a machine, it's a force of nature that we've managed to tame. It's the reason we have motorsport, the reason we have road trips, and the reason we can hear a Ferrari approaching from half a mile away. It is the sound of power, the smell of adventure, and the very essence of mechanical brilliance. This incredible device powers almost everything that moves in our world, from the humble lawnmower that tidies up your garden to the colossal container ships that bring you your trainers from the other side of the planet. It's a testament to human ingenuity. We looked at a puddle of flammable liquid and thought, I know, let's set fire to that inside a confined space and see what happens. And what happened was the modern world. It was noisy, a bit smelly, and utterly, utterly brilliant. The internal combustion engine isn't just a piece of machinery, it's the provider of power, the giver of speed, and the creator of glorious, glorious noise. It is quite simply magnificent. The basic principle behind this mechanical marvel is astonishingly simple, something even a child could grasp. It all comes down to a fundamental law of physics. When you heat a gas, it expands rapidly. Think about a can of fizzy pop. You shake it up, you agitate the gas inside, and when you open it, it sprays everywhere. The engine does something similar, but on a much more violent and productive scale. It takes a small amount of fuel, mixes it with air, and then ignites it. The resulting explosion creates a massive amount of hot, high-pressure gas that pushes outwards with incredible force. It's this push, this shove, that is the source of all the power. It's a bit like a cannon. In an old-fashioned cannon, you stuff gunpowder down the barrel, ram a cannonball on top, and light a fuse. The gunpowder explodes, creating a huge volume of gas that has nowhere to go except forward, pushing the cannonball out at a tremendous speed. The internal combustion engine is just a collection of very small, very fast cannons, all firing in a precise order. The cannonball in this case is a metal plunger called a piston. The explosion forces the piston down, and this movement is what we use to turn the wheels. It's a beautifully simple idea, executed with incredible precision and engineering genius. Let's use another example. Imagine you have a bicycle pump. When you push the handle down, you are compressing the air inside the tube. Now imagine that instead of you pushing the handle, a small firecracker went off inside the pump. The explosion would force the handle to shoot upwards all by itself. That's the magic of internal combustion. It's not you doing the work, it's the fuel. The engine's job is to manage these explosions, to make sure they happen at exactly the right moment to keep everything moving smoothly. It's a continuous cycle of tiny controlled detonations providing a constant stream of power. This process of converting chemical energy, stored in the fuel, into mechanical energy, the movement of parts, is the secret to its success. It's an incredibly effective way to pack a lot of power into a relatively small and lightweight package. You can carry a tank full of petrol, which is just stored energy, and the engine will release that energy bit by bit, explosion by explosion, to take you hundreds of miles. It's this energy density that has made the internal combustion engine the undisputed king of the road for over a century. It's a chemical reaction turned into a mechanical symphony, a process of pure, unadulterated power generation. Now let's pop the bonnet and get our hands dirty. The engine might look like a complicated lump of metal, and well, it is, but it's built around a few key components that do all the important work. The main stage for our fiery drama is the cylinder. This is a perfectly round, hollow tube bored into the main engine block. It's the chamber where all the magic happens, the little cannon barrel where the fuel and air are burned. Most cars have at least 4 of these cylinders, but proper cars, the ones that make you grin, have 6, 8, 10, or even 12. More cylinders usually means more power, and more power is always better. Inside each cylinder, you'll find the piston. This is a solid, cylindrical plunger made of metal that fits snugly inside the cylinder, a bit like a syringe. The piston is the part that gets shoved by the explosion. It's designed to slide up and down inside the cylinder thousands of times a minute without wearing out. Attached to the bottom of the piston is a connecting rod, which, as the name suggests, connects the piston to the crankshaft. The crankshaft is a wonderfully clever piece of engineering. It's a long, rotating shaft with a series of cranks or throws that convert the up and down motion of the pistons into rotary motion, just like your legs pumping pedals on a bicycle. At the top of the cylinder, you have the cylinder head, which acts as a lid. Set into this lid are at least 2 valves. Think of them as tiny, high-tech doors. One is the intake valve, which opens to let the mixture of fuel and air into the cylinder. The other is the exhaust valve, which opens to let the burnt gases out after the explosion. These valves are opened and closed at precisely the right moments by a rotating shaft called a camshaft. And finally, the star of the show, the spark plug. This little device pokes into the cylinder and creates a tiny bolt of lightning, an electric spark, that ignites the fuel and air mixture, starting the whole process. So you have the cylinder as the room, the piston as the moving floor, the valves as the doors, and the spark plug as the light switch that starts the party. All these parts have to work together in perfect harmony, with timing that is measured in fractions of a second. The crankshaft spins, turning the camshaft, which opens and closes the valves, while the piston slides up and down, and the spark plug fires at the exact right millisecond. It's a mechanical ballet of incredible complexity and precision, all happening in a hot, violent environment. It's a miracle of engineering that it works at all, let alone for hundreds of thousands of miles. Most car engines operate on what is known as the 4-stroke cycle. It's a simple and elegant sequence of events that repeats over and over to create power. You can remember it with the simple mantra, suck, squeeze, bang, blow. It's a 4-act play that takes place in each cylinder. The first stroke, or act, is the intake stroke. The piston starts at the top of the cylinder and moves downwards. As it does, the intake valve opens, creating a vacuum that sucks a mixture of air and fuel into the cylinder, filling the space above the piston. It's like pulling back the plunger on a syringe to draw liquid in. Suck. The second stroke is the compression stroke. Now the intake valve closes, sealing the cylinder. The piston reverses direction and travels back up, squeezing the air and fuel mixture into a much smaller space at the top of the cylinder. This compression makes the mixture much more volatile and ready to explode, a bit like shaking a can of fizzy drink to build up the pressure inside. The more you squeeze it, the bigger the eventual bang will be. This is a crucial step for generating a powerful explosion. Squeeze. It's the calm before the storm, the moment of anticipation before the real action begins. The third stroke is the one we've all been waiting for, the power stroke. With the piston at the very top of its travel and the air-fuel mixture tightly compressed, the spark plug fires. Bang! This ignites the mixture, causing a massive and instantaneous explosion. The incredible pressure from this explosion forces the piston down the cylinder with tremendous force. This is the stroke that does all the work. It's the big push that turns the crankshaft, which ultimately turns the wheels of the car and propels you down the road with a massive grin on your face. This single violent event is the source of all the engine's power and glory. Finally, we have the fourth stroke, the exhaust stroke. After the power stroke, the cylinder is full of hot, useless, burnt gases. The piston moves back up the cylinder one last time. As it does, the exhaust valve opens and the piston pushes all the waste gases out of the cylinder and into the exhaust system, where they eventually exit through the tailpipe, making a lovely noise as they do so. Blow. Once the piston reaches the top, the exhaust valve closes, the intake valve opens, and the whole four-stroke cycle begins all over again. This entire ballet happens hundreds of times every minute in every single cylinder. For an engine to produce power, it needs the perfect meal. And that meal is a very specific cocktail of fuel and air. You can't just pour petrol into the cylinder and hope for the best. It needs to be mixed with just the right amount of air to burn properly. The ideal ratio, the perfect recipe for combustion, is about 14.7 parts air to 1 part fuel. This is known as the stoichiometric ratio. If you have too much fuel, the engine runs rich, wasting fuel and creating soot. If you have too little fuel, it runs lean, which can cause it to overheat and lose power. Getting this mixture just right is absolutely critical for performance and efficiency. In older cars, this job was handled by a wonderfully mechanical device called a carburetor. It was a sort of tube that used the vacuum created by the engine to suck fuel into the airflow. It was simple, but not very precise, and was often affected by things like temperature and altitude. Modern cars, however, use a much cleverer system called fuel injection. This system uses a computer, the engine control unit, or ECU, to control everything. The ECU reads information from dozens of sensors around the engine, measuring airflow, temperature, and engine speed. It then calculates the exact amount of fuel needed for that precise moment. The fuel injectors are essentially very sophisticated, electronically controlled nozzles. They spray a fine mist or aerosol of fuel directly into the air as it enters the cylinder, or sometimes directly into the cylinder itself. This creates a much more consistent and evenly distributed air-fuel mixture, which burns more completely and efficiently. This precision is what allows modern engines to be so much more powerful, economical, and cleaner than their ancestors. It's the difference between a chef just chucking ingredients in a pot and a Michelin-starred master weighing everything to the nearest milligram. The result is a much better, more powerful explosion. Once this perfect mixture is inside the cylinder and has been compressed, it's time for the magic spark. The spark plug is a small but vital component. It has two small pieces of metal called electrodes, with a tiny gap between them. The car's ignition system sends a very high voltage pulse of electricity to the spark plug, which is powerful enough to jump across this gap. This creates a short, intense spark, like a miniature bolt of lightning. This spark is all it takes to ignite the highly compressed and volatile fuel-air mixture, kicking off the power stroke. It's the match that lights the fuse on our tiny cannon. So why has this fire-breathing beast been the king of personal transportation for more than a century? The answer is simple. It's brilliant at what it does. The primary reason is its incredible power-to-weight ratio. You can get a huge amount of power out of a relatively small and light engine. This is crucial for vehicles like cars and motorcycles, where you don't want to be lugging around a power source that weighs as much as a house. An internal combustion engine can be small enough to fit in a motorcycle frame or powerful enough to propel a multi-ton lorry up a steep hill, all while being reasonably compact. Another huge advantage is convenience, and that comes down to the fuel. Petrol and diesel are forms of liquid energy that are incredibly dense. A small tank of fuel can take you hundreds of miles, and when you run out, refueling is a simple matter of spending 5 minutes at a filling station. You can find these stations everywhere, from the middle of a bustling city to the most remote corners of the countryside. This vast, established infrastructure means you have the freedom to go almost anywhere, anytime, without worrying about where your next charge is coming from. It's a level of convenience and freedom that is, for now, unmatched. And then there's the character. An internal combustion engine is not a silent, soulless box. It has a personality. It vibrates, it rumbles, it roars. The sound of a V8 engine at full throttle, the burble of a flat six on the overrun, or the high-pitched scream of a superbike engine is pure automotive music. It's an emotional, visceral experience that connects the driver to the machine. It tells you what it's doing. You can feel the power building through the vibrations in your seat. This sensory feedback is a huge part of the joy of driving, something that a silent appliance on wheels can never replicate. It's the sound and feeling of power. This is why it's the heart of not just our transport, but our passion. Cars and motorcycles with internal combustion engines are not just tools to get from A to B. They can be works of art, feats of engineering, and sources of immense pleasure. They are the basis for motorsport, for road trips, for the simple Sunday drive. They have defined our culture, shaped our cities, and given us a sense of personal freedom that was unimaginable before their invention. The internal combustion engine isn't just a motor, it's the engine of adventure, and that is why it has reigned supreme for so long. Now there's a new challenger in the ring, the electric motor. It's quiet, it's clean, and it's being hailed by many as the future. So how does it stack up against our glorious fire-breathing champion? Well, an electric motor works on a completely different principle. Instead of burning fuel, it uses electricity stored in a battery to create a magnetic field, which causes the motor to spin. It's much simpler, with far fewer moving parts. There are no pistons, no valves, no crankshaft, and no explosions. It's more like a kitchen appliance than a proper engine. It's silent, smooth, and very, very different. The big selling point for electric cars is their instant torque. Because an electric motor delivers its maximum power from the moment it starts spinning, they are astonishingly quick off the line. You press the pedal and whoosh, you're gone. There's no waiting for the engine to build revs. The power is just there, instantly. This can make them feel incredibly fast in city driving. However, our champion, the internal combustion engine, fights back with its character and stamina. The sound, the vibrations, the crescendo of power as you climb through the gears, that's an experience an electric car simply cannot deliver. It's the difference between listening to a live orchestra and a computer-generated tune. The biggest hurdle for the electric challenger is the battery. While a tank of petrol can be filled in 5 minutes, recharging a large battery can take hours. This is what we call range anxiety. The fear of being stranded in the middle of nowhere with a dead battery and a long wait ahead. Furthermore, batteries are incredibly heavy, which affects a car's handling and agility. A petrol engine gives you a lightweight power source and a quick refuel, offering a freedom and spontaneity that electric cars are still struggling to match. The internal combustion engine offers long-distance capability and convenience that is, as yet, undefeated. Ultimately, it's a battle of philosophies. The electric motor is efficient, quiet, and logical. It's the sensible choice, the head-over-heart decision. The internal combustion engine, on the other hand, is passionate, noisy, and emotional. It's a celebration of mechanical complexity and raw, explosive power. While the electric motor is undoubtedly clever, it lacks the soul, the drama, and the sheer, unadulterated theater of an engine that makes power by setting fire to things. The electric motor may be the brain, but the internal combustion engine will always be the heart. We have to be honest. For all its brilliance, the internal combustion engine has a dark side. It's a bit like a rock star, loud, powerful, and thrilling, but also messy and responsible for some unpleasant emissions. The blow part of the 4-stroke cycle, the exhaust, releases a cocktail of gases into the atmosphere. The main culprits are carbon dioxide, which is a greenhouse gas that contributes to climate change, and nitrogen oxides and particulates, which can cause smog and are harmful to human health. This is the price we have paid for a century of automotive freedom. The pros, as we've discussed, are immense. The power, the convenience of refueling, the established global infrastructure, and the sheer joy it brings to millions of enthusiasts are undeniable. It has powered our economies, connected our communities, and enabled a level of personal mobility that was once the stuff of science fiction. It has given us the ability to explore, to trade, and to race. In many ways, the modern world was built on the back of the internal combustion engine. It's a legacy of power and progress that is impossible to ignore, a testament to what we can achieve with a bit of fire and ingenuity. However, the cons are becoming more and more pressing. Our cities are choked with traffic, and air quality is a major concern in many parts of the world. The reliance on fossil fuels also makes us vulnerable to price fluctuations and geopolitical issues. And of course, there is the growing awareness of our impact on the environment. The very thing that made the engine so great, burning fossil fuels, is now its greatest weakness. Society is demanding cleaner, more sustainable ways to get around, and the old, smoky engine of the past is facing pressure to clean up its act or get off the stage. This is the great challenge for the internal combustion engine today. Can it retain its crown while addressing its flaws? Can we have the power and the passion without the pollution? Engineers are working tirelessly to answer this question. The debate over its future is fierce. On one side, you have those who see it as a relic, a dinosaur destined for extinction. On the other, you have those who believe it can be evolved and adapted to meet the challenges of the 21st century. It's a battle for its very survival, a race to see if this magnificent beast can learn new tricks. So, is the internal combustion engine on its deathbed? Is it time to write the obituary? I say, not a chance. Rumors of its death have been greatly exaggerated. The engine isn't dying, it's evolving. It's getting smarter, cleaner, and more efficient than ever before. Engineers are not just sitting around waiting for the electric motor to take over. They are fighting back with some incredibly clever technology. The future of the internal combustion engine is not about giving up, but about getting better. This old dog is learning some very new and impressive tricks. One of the most significant developments is the hybrid powertrain. This is a brilliant compromise, the best of both worlds. It combines a smaller, more efficient petrol engine with an electric motor and a small battery. The electric motor can handle low-speed city driving, running silently and with zero emissions. But when you need more power, or you're out on the open road, the petrol engine kicks in, providing the range and performance we love. This means you get the fuel economy of a small car with the power of a big one, all while slashing emissions. It's a clever solution that proves the engine still has a vital role to play. Engineers are also looking at the fuel itself. They are developing new, cleaner-burning synthetic fuels, or e-fuels, which are created using renewable energy. These fuels are carbon neutral, meaning they only release as much carbon dioxide when burned as was captured from the atmosphere to